Welcome to this training on traditional software development process models. A software development process model is also called software lifecycle. I will use both expressions in this training. In this part of the training I will give you some information about the waterfall model. The waterfall model is believed to have been the first process model which was introduced in software engineering. Originally the model was presented 1956 in a conference by Herbert D. Bennington. Basically it was derived from the process of mechanical engineering. In 1970 Winston W. Royce published the first formal version of the model, although he did not use the expression waterfall model. However, he used it as an example for a model that does not work. In spite of it, the original presentation of Bennington was relaunched in 1983, and the waterfall model can be considered to be fully established at the time.
The number of the steps in the waterfall model is not defined. It can be tailored as appropriate for the product that shall be developed using this life cycle. Therefore, it could be used for system development, or like in this example for pure software development. The waterfall model is strictly sequential and uses a top-down approach. The earlier phases deal with requirements, followed by design, before coding or any other form of implementation is started. Consequently, the later phases deal with test, followed by the production and maintenance of a product. The waterfall model is an entirely document-focused model. This means that each phase has a certain document or a set of documents as its output. The documents of the earlier phases usually serve as inputs for the subsequent phases. If the model is applied to other than just software development, there may be other outputs, such as hardware samples or database records, rather than documents. Therefore, it is better to speak of the work products assigned to the phases, rather than of documents. Only at the end of the life cycle we find an output work product, that is the main target of the development, and eventually will be produced and sold.
An important approach of the waterfall model is that one phase has to be completed before the next phase can be started. For better visibility I show only two phases and the transition between the two phases in this example. Of course the same principle applies to all other phases defined in the model. A phase is considered to be completed as soon as the assigned work products have been established and verified. Verification can be done, for example, by a document review. Sometimes so-called gates or milestones are invented to check and assure that a phase has been completed. Only after this gate has been passed, the next phase or activity of the waterfall model can be started. Passing a gate can be, for example, a decision meeting or management signature. Iterations between two subsequent phases are usually not possible, or required to run the complete process again. Now let us look at the advantages and disadvantages of the waterfall model. The advantage of the model is that the phases are clearly separated from each other, and it is clear what is expected in each phase of the product life cycle. This allows a simple planning and control of any development project following this process. If the requirements are fixed and stable, this model allows an exact estimation of the required efforts and costs to run the project. However, there are also a lot of disadvantages of this product life cycle. The disadvantage of the waterfall model is that in real-life phases cannot be strictly separated. Phases may overlap and run in parallel for a certain time. Iteration loops between subsequent phases are usually needed, and there may be even a need for iteration loops jumping back over one or two phases. This cannot be reflected in the model. A strong sequential approach as it is demanded by the waterfall model is not necessary and not productive in real life. For example, tests could be already set up for finished software modules, while other modules are still in the coding phase. This means that overlapping phases are usually more productive and save development time. Requirements are rarely complete at the start of a project. Requirements might change, or new requirements may be added, throughout the lifetime of a project. Following a strict waterfall approach, this would mean to restart at the beginning of the product life cycle, each time requirements changed. Errors in the new product are discovered very late in the testing phase. Bug fixes would require the project to run through the complete product life cycle again. The product is available late. There is no chance to deliver a product sample until the end of the product life cycle is reached. This requires a lot of patience from your customer. The danger is that the product is outdated at that time, or that the customer does not accept it, and the development has to be started all over again. When the model was first presented by Bennington in 1956, the world of computing was very different to what we know now. Programs were very small, and what you could expect of a program was very little. Sorting punch cards, adding a few columns of numbers, printing the results or punching some other cards as a result, was the usual job a program had to do. The programs of 1956 can be hardly called software, if you compare it with today's millions of code lines in modern programs and operating systems. The following film may illustrate the way of computing in the year 1965, which is 9 years later than the first presentation of the waterfall model. It shows a PDP-8 computer, using a paper tape that contained the program. This was a high-end machine at that time, and it shows how computing was still a lot based on mechanics, the discipline from which the waterfall model was originally derived.
Therefore, Bennington's waterfall model has to be regarded as purely academic. The innovation was that the first time software engineering was divided into separate phases, like a requirements phase, a design phase, implementation phase, and so on. Just the same, like they did in mechanical engineering. However, the demands of the time for a process model were so small that the waterfall model remained basically without attention for many years. As programs became bigger, the need for a better requirements phase, some more thoughts on the design, and better testing were needed. Programmers found it more and more difficult to keep an abstract of the program in their mind and transfer it into code. Also, the thought of having a separate testing phase performed by dedicated testers evolved between the late 1960s and 1970s. The different phases of software engineering were identified, and the waterfall model was at hand and therefore came in fashion, although it already was outdated at that time. We should not forget that in 1970 Winston W. Royce considered the waterfall model as unsuitable and not working. The use of the waterfall model may still have some justification for projects that are small, and where requirements for the project are clear and stable. The waterfall model is still used to visualize overall product life cycles, although you will rather find a chevron type of visualization than a cascade. This is simply because a chevron diagram is very common and in the same way sequential as a cascade would be. This use of the model still makes sense. As shown in this example, the life cycle of a product can be split into several bigger phases, like a business case, a concept and prototyping phase, a design phase, aimed at maturity for series production, and finally the production itself and the subsequent maintenance phase. Each phase is clearly separated from each other, and responsibilities will change between disciplines and departments of a company, from one phase to the next. It is easy and even necessary to establish clear rules for the handover of intermediate work products, and have gates for completeness checks between the individual phases.
Inside these general phases, you should select more appropriate development models for each phase. The output and result of such a development model should be, of course, just the expected output of the respective phase in the overall product life cycle. There are several development models available, which match quite well. For example, a spiral model would be a good candidate to be used in a concept and prototyping phase, whereas you might select one of the agile methods, like extreme programming or Scrum, for the actual development phase. This is the end of our lecture on the waterfall model. Thank you for watching.